Hi again. In this video, we're going to keep going with categorical variables, but now we're going to look at two categorical variables and continue with probability as well. Okay, so we have an example here, a study on treatments for addiction to cocaine. And in this study, researchers randomly assigned 72 chronic users of cocaine into three groups. Discipramine was given to one group, which is an antidepressant, lithium, which is a standard treatment for cocaine, and a placebo. So this is an experimental design, kind of like we have learned about before. And then the results of the study are summarized in this table. Okay, so our two variables are, first of all, the treatment group. So one is in the rows. The rows are discipramine, lithium, and placebo. So this is one variable is the group that the person is in, the group or the treatment. And then the other variable is whether or not the person had a relapse. So whether they started using cocaine again, that would be a relapse. And if they did not start using cocaine again, that's no relapse. Okay, and we also have a total column and a total row, and our grand total in the very right lower corner. I'm going to call that the grand total because there's a lot of totals, right? There's row totals, column totals, and a grand total. Okay, so the group or treatment is one variable. Let me write that in the rows. And then the results, whether they had a relapse or not, is the other variable. In the last video, I was saying there's other ways to display categorical variables, and I was actually thinking about when you have two variables. So when you have one, like in the last video, it's really just a bar chart or a pie chart. And we're not going to go into visualizing these, but there are some things like mosaic plots that you may have seen before. So that's what I was thinking about. Okay, so we're going to use these. So first of all, this is coming from real data. So this is an example of a study that was done. And we're going to use these to do sample proportions again. And we're going to also call those probabilities, okay? If we selected a participant at random, what's the chance they had a relapse? So that's our first question. And this is a marginal probability. So we're going to learn a few different types. Think of a margin as the total, like a margin on a page is the edge of your page. So a margin in probability in a table is the total row or column, okay? So we call it a marginal probability. It has to do with the total. If we select a participant at random, what's the probability they had a relapse? Okay, so we're going to look in the table and see where are all the people that had a relapse. Okay, so I'm going to look in the relapse. In this case, it's a column. And then it doesn't say anything about which group they were in, so I'm going to use the total. Okay, so I'm going to write the probability that I'm finding. That's like showing your work. Probability of relapse. That is equal to the total of 48 out of our grand total of 72. So let me find out what that is. 48 out of 72 is 0.666, and then I'm going to have to round that to a 7. Okay. And then we can also, it's good to write a sentence as well. So we could say 66.67% of the participants relapsed. Okay, that's quite a lot, right? Addiction is very challenging. Okay. Let's do another one. What is the percentage of participants who were given lithium in the study? So now we're going to write probability lithium. This is in a row. All the people who were given lithium are in the middle row, and Doesn't say anything about whether they had a relapse or not. So we're looking for the total, 24 out of 72. Okay, so you might notice both of these only used one variable. So that's one thing that's unique to marginal probabilities. We're just looking at one variable. They didn't mention anything about the other variable. Okay, you might know if you saw this as 24, 24, 24, you might know what proportion that's going to be. 24 out of 72, yep, should be 1/3, 0.3333. Okay, so 33.33%. It's a coincidence that it's the complement of the relapse, right? Because these are two different variables. They're not relating to each other. 33.33% of the participants were in the lithium group. Okay, and there's a note at the bottom here. These are called marginal probabilities because we use the numbers in the margins. We use the total for a single variable over the grand total. Okay, so that's one type of probability that we're finding. The next one is called a joint probability. And the key word is and. So we're looking at two things happening now together. So letter C is, what's the probability that a person took dicipramine and had a relapse? Okay, so I'm going to underline the different things. Took dicipramine and had a relapse. So to write that out, I'm going to write probability dicipramine and relapse. Takes a little longer to write that out, so I'm going to, or more space, so I'm going to go down to the next line. Okay, so look back at our table. Dicipramine, look at who took dicipramine and had a relapse. How many people? So that is an intersection of a row and a column, right? Because we have one category from each variable. And it's and, meaning they have to have both. So that means it's a single number in the intersection. So that would be 10 out of our grand total of 72. 10 out of 72. And I'm going to write the note up here that this is the intersection over grand total. Okay, so 10 out of 72, let's calculate that. That is 0.13888, so 1389. Okay, so 13.89% of the participants took dicipramine and had a relapse. Okay, so this is out of all the people, right, who took any treatment. All the people who were in the study. Okay, let's practice with another one. What's the probability that a participant had the placebo and had a relapse? Okay, so was in the placebo group and had a relapse. Okay, so placebo and relapse. So now we're the third group down, and relapse is 20 in the intersection. Oops, I should have written what I was trying to find first. Probability, placebo, and relapse. The intersection there is 20 people out of 72. Okay, it should be double what our last one was. 20 divided by 72 is 0.27777, so it'll be 2778. 27.78% of participants had the placebo and had a relapse. If you're wondering which group was the most successful, we're getting to that. But we're using this to practice how to find these probabilities. Okay, and here's a note at the bottom. These are called joint probabilities because they're the intersection between two variables. And they're also sometimes called AND probabilities. And I often put the AND in quotes because AND is just a regular word and it can be confusing. Okay, so let's do one more type, and that's OR. So I'm going to go to the next notes page here. We had marginal, we had joint, and now we have OR, which doesn't have a special name other than just OR. This is when we want to do, oops, too high. We want to look at one thing or another thing occurred, okay? So there's two different possibilities in this. It depends on whether the events are disjoint or not. So let me explain what that means, disjoint or not. So disjoint events cannot occur at the same time, or they share no common outcomes. For example, a chip cannot be green and black at the same time. Okay, so those are disjoint things. So those are mutually exclusive. Mutually exclusive is another same meaning as disjoint. It's just another phrase for it. Okay, so if A and B are disjoint events, then we can just go ahead and add them together. Probability of A or B is the probability of A plus the probability of B. And we saw that when we were looking at eye color. I forget which eye colors we were adding, but if it was blue and green, we added those two together because we added all the people that had those colors of eyes. Now, when we have two variables, though, we might have an overlap, and that's called non-disjoint. Those are events that can occur at the same time, meaning a person or item can hold more than one characteristic. And that's what's going on in here, because each person has two characteristics. They're in a certain group, and they had a certain result, a relapse or not. And so we have to be a little bit careful, and I'll show you how to do this. But when we add them together, then we're counting the intersection twice. And so we're going to have to subtract the intersection out. So this is what it looks like in symbols. Probability of A or B is equal to the probability of A plus the probability of B minus the intersection A and B. Okay, so let me show you why that is, in case it's not clear yet. Hopefully it will be. So question E, if we select a participant at random, what's the probability they were given disipramine or lithium? Okay, disipramine or lithium. So is that possible that they were given both? No, right? Because each person was in one of the treatment groups, and so these are disjoints. The question is, are these disjoint events or not? So these are disjoint. Events, only one treatment. Per person. Okay, so then if we do probability of disipramine or lithium. So what's the chance they were given one of the two treatments and not the placebo? Then, and again, they're not talking about relapse or not, so we would go all the way over to the total, disipramine and lithium, so that would be 24 plus 24 out of 72. So that should be 2/3, right? It's 2/3 of the study, 2/3 of the people. 24 plus 24, and I hit enter. Divide by 72.6667. Okay, so 66.67% of the people were given desipramine or lithium. Okay, so these were disjoint. Let's see what letter F says. What is the, that's funny, it says, what is the problem? What is the probability? I'd like to say that is an autocorrect issue, but I don't know, so I'll fix that in the notes. What is the probability they had lithium or relapsed? Okay, now are these disjoint or not? So let's look and see. Lithium or relapsed. If there was a 0 there, then they would be disjoint because there wouldn't be anyone where both of those happened. But since we have 18 people, it is, they are not disjoint. It's a negative word, so it's a double negative. Okay, so I'm going to write that 18 people had lithium and relapsed. So they are not disjoint, meaning there is an overlap. They overlap. Okay, so then to find this probability, I'm going to show you what happens. Probability of lithium or relapse. I'm going to show you two ways to do it. First, I'm going to use the subtraction way that's in this formula. So if we need to find what's the number of people who took lithium. So that would be overall would be 24 plus the number of people that had a relapse is 48. Okay, so do you see what happened? If I add the 24 plus the 48, the 18 is in both of those totals. So the 18 gets counted twice. So that's too many people. That's more people than we have in those two groups. So we need to subtract the 18 once. That means we're still counting them, but we're counting them once and not twice. Okay, so that's why we subtract that intersection out. So sometimes I call this the addition way of doing it, and this is out of 72. Actually, maybe I call it the subtraction way. We're doing both. 24 plus 48 minus 18, that's 54 out of 72 is 75%, 0.75. Now there's another way to do it. You might have thought about that as well. If you don't want to go through the subtraction, we could use one of the totals and then some of the interior numbers. So actually there's several ways to do this. I could add 10 plus 18 plus 20 plus 6. So I could add all those numbers. Or as a little shortcut, I could do 48 plus 6. Or I could do 24 plus 10 plus 20. So there's many ways to do this one. So I'm going to just to show you, I think I do call this the addition way. So if we added all the numbers separately, it would be 10 plus 18 plus 20 plus 6 out of 72. Now we should get the same thing. Let's double check. 10 plus 18 plus 20 plus 6 is 54. I think that's what we got out of 72. Yep. 0.75. Okay, so it doesn't matter to me which way you do it. That's why you show your work. So just show your steps, and that'll be great. Okay, one more note before we end this video. I wanted to talk about, you may have noticed the empirical in the title of the video. Empirical versus theoretical probabilities. So an empirical probability is calculated from data, an experiment, or a simulation. And we've done some of these things like flipping coins, running a computer simulation, or calculating something from data. Okay, so that's mostly what we're doing in this class, empirical probabilities. Keep in mind there's always variation with empirical. There's always variation with experiment, simulation, and data, right? So, right, always has variation. It's imperfect, in other words. A theoretical probability is calculated using a mathematical model or formula. So for example, with a coin, the idea that it's 50-50, so the probability of heads is 1/2. We wouldn't necessarily get 1/2 all the time by flipping a coin, but theoretically that's the probability. So we'll look at theoretical probabilities more at the end of the course. For right now, we're doing mostly empirical, so I wanted you to know the difference between the two, and that empirical always has variation. Okay? Okay, great. Well, I'll see you in the next video.